Overall, our lab is interested in interfacial phenomena and in colloidal systems, and we have funding from National Science Foundation and American Chemical Society Petroleum Research Fund. The interest in some of the projects are looking at foams, and the foam is basically a colloidal dispersion where you have bubbles dispersed in a background liquid, right? So this can be air bubbles in water, this can be foam in your cappuccino, this can be whipped cream. So all of these are examples of foam.
We basically talk about the instability of the foam. It's a thermodynamically unstable system, and people have always tried to figure out a way to make it more stable. So what we do is we look at the characteristics of the foam and what makes it unstable, and we try to tweak and change these characteristics to make it more stable.
We do that by using this dynamic foam analyzer right over here, which we can use to sparge the particle solutions to generate the foam. That can be used then to look at the characteristics such as bubble size, bubble area, how long they are stable, how much foam is generated over time, and all this to get to the real intricacies of the microstructure as well as destabilization mechanisms that are used, which destabilize the foams and cause them to break over time.
I do research here with colloids and surfactants at interfaces, and usually what I'm doing is working with the tensiometer here, which measures like the shape of drops or bubbles. These bubbles, for example, that I'm measuring right now, there are air bubbles inside a solution of surfactants, and this solution of surfactants contain these molecules that are likely to, they like to go to the interface, and they like to be there, and they lower the surface energy of that interface, and thus reducing the overall surface energy of the system. And this is used to stabilize emulsions, foams, in several different applications of the industries.
My research focuses on first the synthesis, the stabilization, and the functionalization of silver nanoparticles with these groups that are favorable for CO2 separation. So these nanoparticles that we are making will be incorporated into a polymer membrane for gas separation, which would be useful in like the natural gas industries or other industries. And the whole purpose of this is current separation techniques can be quite extensive and quite expensive for such as distillation, which is very energy intensive. And so the purpose of material science is kind of developing these new materials that we can incorporate into membranes to produce the more energy efficient process.
My research focuses on studying a system of similarly charged species, specifically SDS surfactant molecules and silica nanoparticles. And we're mainly trying to see if SDS will adsorb onto the surface of these nanoparticles. It's a debated topic because they're both similarly charged. And so we use the Langmuir trough to do this because it can give us information about the surface tension of the system. And some applications of this research is it can be used to improve CO2 sequestration methods and wastewater treatment, because when the SDS adsorbs onto the particle surface, there's increased interparticle repulsion, which stabilizes the system.
Stability of these systems is going to depend on what is in that dispersion, right? So oftentimes, either there is a molecule present, think about like surfactants in your detergent, and that helps with the stability of these foams, or particles that are added to the system, such as silica or calcium carbonate. So the idea is, how can we understand the properties of these particles from their shape, their surface visibility, hydrophilic, hydrophobic, their roughness, smoothness, their chemical anisotropy, and how can we tune that to then understand the resulting performance, and not only under static conditions, just having a foam sit there, but also what happens when you flow it, right? So if you have to flow this foam subsurface, if you have to flow it in a pipe, right, so in a microchannel, how would the behavior change if you were to change the properties of that stabilizer? For production and separation of hydrogen, our expertise in interfacial science will be really important.